What is inverse variation? So we say that y varies inversely with x, or that y is inversely proportional to x, if for all corresponding x and y values, that means for every single x and y value that go together, every ordered pair, their product equals a constant, the same constant, over and over again. We call this constant the constant of variation, and we use the letter k to represent it. So we've got this equation right here for inverse variation. It's just y equals k over x, and this is always the format that it's going to be in. Remember that our parent function, our parent rational function, was just y equals 1 over x. So when we do these problems today with inverse variation, we're going to be solving for different values of k. So we're not only going to have the number 1 here in our numerator, it'll be a lot of different values. So look at this graph and remember that we always have a vertical asymptote right here at x equals 0, and we also have a horizontal asymptote right here at y equals 0. Also, notice that as your x value increases, so as we move from left to right, as x gets bigger and bigger and bigger and bigger, our y value decreases. And then, of course, we butt up against this asymptote right here, and then our function jumps to the other side. And again, as our x value begins to increase on this side of our graph, the y value is decreasing again. Okay, so that's what our inverse function is always going to look like. All right, now let's look at this equation right here and isolate our k value. What are we going to do to get k by itself? And hopefully from Algebra 1, you remember that all you've got to do is the opposite operation. What's the opposite of dividing by x? Well, let's just multiply by x. So if I multiply this side of my equation by x, I would have to multiply this side of my equation by x. And that would give us k equals just x times y. This is our constant of variation, okay? That's what we said up here in this little paragraph. It's always the product of x and y. So let's look at a couple of examples. Determine if the following tables represent an inverse variation, and if so, what's the k value? So I'm going to show you guys these examples on the left side, and y'all can practice on the right side. Okay, so determine if it's inverse variation. Again, let's check to see if we have a constant of variation that exists. Okay, so when I look at my first x value and y value that are corresponding, they go together. If I were to multiply those together, -9 times -4 gives us a positive 36. All right, take the next corresponding x and y value. That gives us -18 times -2, which again multiplies to give positive 36. So far, so good. Take our next corresponding set of values. That would mean k is equal to -6 times -6, which of course is positive 36. And our last corresponding set of values, k would equal -12 times -3, which is still positive 36. And yes, I know it seems tedious, but you do need to check every pair in the table. If even one pair deviates from our pattern, then it's not representative of inverse variation. So yes, this is inverse variation, and here our k value is equal to 36. Okay? Let's try another one. Says, determine if the following table represents inverse variation. Well, let's multiply again. We've got positive 3 times positive 6. What is positive 3 times positive 6? That gives us 18. If I go to the next corresponding pair of values, I see a positive 4 times a positive 8. Well, 4 times 8 is 32. So it's already fallen apart. This is not inverse variation. Not inverse variation. Because when I multiplied corresponding x and y values, I had this pair have a product that was different from this pair. So automatically it's not inverse variation. Okay? We can do one more. Let's do the one to the right. It says determine if the following is inverse variation again. All right, so let's multiply together our first pair, 36 times 2. That x times y value gives us 72, okay? The next corresponding pair is just 8 times 9. Well, that's also 72, so that looks nice. Then I have a corresponding pair of 24 and 3. 24 times 3 is also 72. And then we have our last pair of corresponding x and y values. We have 12 times 6, which also makes 72. So this is definitely a table that represents inverse variation, and this k value is just 72. All right? Let's do a little side note. Remember, this is just our constant of variation. This k is our constant of variation. So if I wanted to write the equation that represents this table of values, I would just use the format y equals the k value over x. And in this case, our k value is 72. So it's y equals 72 over x. If you were to graph this in your calculator on Desmos and then pull up a table of values, you would find these values in that table. All right, let's do some more. It says, if y varies inversely with x and y equals 3 when x equals 5, what is the constant of variation? Well, because we were told that y varies inversely with x, we can set up our equation, our little formula, k equals x times y. We know that, okay? So in this problem, our k value is going to equal 5 times 3. What is 5 times 3? 15. So the formula or the equation for this relationship is just y equals 15 over x. Okay, let's try one more. It says y varies inversely with x, and we have to be told that. We can never just assume. Y varies inversely with x. So we know we can find a k value. Our k value is always going to equal x times y. And we have a corresponding x and y value pair. My x value is 9, its y value is 2. So k equals 9 times negative 2, which gives us negative 18. So this equation is just y equals negative 18 over x. All right, so now let's take that information and see if we can find other missing values in our function relationship, okay? So if we know that y varies inversely with x, let's highlight. We know y varies inversely with x. We also know that y equals 6 when x is equal to 4. We want to find our y value when x is equal to 8. Okay, so let's set up our equation. We know that y varies inversely with x. So all we've got to do is multiply first. We take our k value, we have x times y, okay? So k equals 4 times 6. And that just gives us a k value of 24. So I can set up my equation. Y is equal to 24 divided by our x variable. Okay, so we want to find our y value when our x value is 8. This x value right here. So all I've got to do is sub in this value, this x equals 8, into our equation. So we have y equals 24 divided by 8. What is 24 divided by 8? That's 3. Okay, so when x equals 8, our y value is equal to 3. So what did we do here? We first decided, okay, if y varies inversely with x, we can find a k value. If we can find a k value, we can sub it into an equation. And if we can sub our k value into an equation, we can find any missing x or y value that we want as long as we know its corresponding value. Let's try one more. If y varies inversely with x, highlight, pay attention, this has to be told to us. Y varies inversely with x. And we also know that y equals 6 when x equals 15. We are going to find the x value when y is 45. Set up your equation every time. Set up your formula for the k value. Our k value is just equal to our x value times our corresponding y value. So what is this k value? 15 times 6, that gives us 90. So our k value is 90. If I know this k value, I can write my equation. Y equals 90 divided by x. Now this time my problem says find x when we're given a y value of 45. So let's sub in 45 right here. 45 equals 90 over x. Well, x is in my denominator. It's not isolated. So if I make this a proportion, right, just put 45 over 1, we can just cross multiply. X times 45 is 45x. 1 times 90 is 90. Divide both sides by 45. And we get x equals 2. So that one took a little bit more work because the variable that we were looking for was in the denominator of our equation, right? All right, so now let's put this into word problems. Heart rates and lifespans of most mammals are inversely related. Kinsley has a cat that lives for about 15.2 years on average and has a heart rate of 126 beats per minute. What is the constant of variation? So what is important in this equation or in this word problem? We know that we have an inverse relationship right here. And the inverse relationship occurs between its years of life and its heart rate in beats per minute. Okay? That's what's inversely related. So let's find our K value. Our K value is just 15.2 times 126. So use your calculator, use Desmos. 15.2 times 126 gives us 1915.2. 1915.2. All right, that's our K value. So let's go ahead and write an equation. Let's say our years of life will equal 1915.2 divided by our heart rate. And I like to use words instead of variables here just to remind me what it is I'm using. If you want to use Y and H, that's fine too if you don't want to write out the words. But a hamster has a heart rate of about 634 beats per minute. About how long will a hamster live? Well, 634, this value right here is our heart rate. So we're going to sub it in right there. So our years, or the hamster's years, are going to equal 1915.2 divided by our heart rate of 634. So divided by 634, which means a hamster lives approximately 3.02 years. 3.02 years. Okay? Let's do one more word problem just because they're so much fun when you can apply math to the real world. Am I right, guys? All right, 2 gears are used to operate a machine. Gear A has 60 teeth, and gear B has 45 teeth. The speed at which you turn gear A is 5,400 RPM. The number of teeth and the speed in RPM are inversely related. Okay, that's important to recognize. The number of teeth and the speed in RPM are inversely related. So what is our constant of variation? So K equals. We need to focus on one gear at a time. So right now it says the speed at which you turn gear A. So let me highlight that in blue. Nope. Let me highlight that in purple. The speed at which you turn gear A is 5,400 RPM. So the two values that we were given for gear A was 60 teeth, or were 60 teeth, times 5,400 RPM. So 60 times 5,400 gives us 324,000. That's our constant of variation. So that's the relationship between the number of teeth and the speed. So the question says, at what speed will gear B turn? Well, they're going to have the same K value. So let's use blue for this equation. So our speed is going to be equal to our constant of variation, which was 324,000, divided by, and gear B has 45 teeth, so divided by 45. So speed and teeth have this inverse relationship. So all we've got to do is, in our calculator, do 324,000 divided by 45, or you can do long division, of course. And that gives us 7,200. Okay, so 7,200 RPM. It's important that you always put your units of measure on this. On any word problem that you do, you always want to talk about context. All right, so that's how you use inverse relations. That's how you use inverse variations. Have fun.